Today, we have with us YouTuber Mikeius, who is going to talk with astronaut Clay Anderson. Mikeius, would you like to tell us, what is your relation with science?
I studied mechanical engineering in college and then I quit so that I could communicate science to the public. So I basically have a popular science show for kids and young adults on YouTube, and amongst other things, but that's my relationship with science. I really like reading about it, I love documentaries, and I wanted to do something in Greek for the YouTube audience in Greece.
Okay, great, thank you. And Clay, what is your relation with science?
I didn't know I would get such a hard question right off the bat, but I studied science in college, getting a degree in physics. I went to University, Iowa State in Iowa in the United States to get a master's degree in aerospace engineering. And at that time, I was hired by NASA in Houston at the Johnson Space Center to work as an engineer. I would spend 15 years as an engineer there, at which time I would be selected in the 17th class of astronaut candidates in 1998. So I spent 15 years as an engineer, 15 years as an astronaut. A little bit of science in between.
All right.
Okay, let's move to our first question, which is to Mikeius. How long do you think that it takes to arrive to the International Space Station? 1, 6 hours, 2, 12 hours, or 3, 24 hours?
12 hours, I would say.
Is this based on what kind of guess?
I guess 6 hours seems a bit too little. I don't think that anything goes as fast like that. I think the procedure of docking and launching and all that will eat up an extra few hours.
Okay, Clay?
So I guess the real answer, Mike, is there's two answers. In the old days, it took about 2 days to launch and rendezvous with the space shuttle or the Russian Soyuz rocket to the International Space Station was about 2 days.
Okay.
Today, we can get to the space station with the Soyuz in about 6 hours.
Damn it. I mean, good for you guys, but damn it.
Okay. You got us here. All right, let's go to the following question, which is related. How long does it take to return from the International Space Station? Is it 1, 1 hour, 2, 2 hours, or 3, 3 hours?
Again, obviously gravity helps. But again, the whole procedure, I'm going to go with a maximum 3 hours, just to be on the safe side.
Clay?
I hope it's 3 hours. I mean, 1 hour seems a bit too rushed.
Yeah, 1 hour is too short.
Yeah.
Usually we undock and we mess around for about an hour and do a deorbit burn. But once you do that final burn to get to Earth, it's less than an hour to get home typically. So I think the answer is really between 2 and 3 hours.
So 3 hours is the right answer. Thank you. Mike.
Yes.
At which height from the Earth's surface does the International Space Station fly?
Okay.
1, 100 kilometers, 2, 200 kilometers, and 3, 400 kilometers.
This could go either way, actually. I'm guessing that at 100 kilometers there's still too much atmosphere, maybe. So I'm gonna go with, again, 400 kilometers, that seems quite a lot, so I'm gonna go with the middle one, 200.
200.
Yes.
Okay.
This is going great.
So today's space station altitude is 400 kilometers or 250 nautical miles in the English system. So.
All right. So I lost again, you can applaud now.
You were close. You were very close.
How much time does the International Space Station need to orbit around the Earth? 1, 10 minutes, 2, 1.5 hours, 3, 1 day.
It can't be one day because the light and dark keeps changing. But again, 10 minutes seems like really fast and dangerous. So I'm going to go with an hour and a half.
And he is correct.
Yes!
An hour and a half. That's what that chemical engineering training did for you right there.
Apparently not much. Oh, it did help me there.
We now go into the category Life in Space. Now, Mike, you have to choose the right answer. One, salt is in liquid form.
In space, obviously, right?
Yes, in space. Mustard has the form of powder. And 3, jam has the form of cubes.
I can't imagine how salt would be in liquid form. Then again, it is NASA. Mustard has the form of powder. You can get that on Earth as well. Jam has the form. I'm going to go with. I'm going to risk it. I'm going to go with 1.
You are correct.
Yes! I knew it.
Bravo, Mike.
How is it in liquid form, by the way?
So tell us a bit about more.
We put, you know, when you do your contact lenses and you have that little bottle and you squirt the drops in.
Yeah,
so we have a little bottle about that size, and we take salt and we dissolve it in liquid so that we have salt water, and then you can squirt drops of salt water because water has surface tension. So that means when you touch the water to your food, it will stay onto the food and you can add salt.
So the correct number is 1. Salt is
1.
in liquid form. Well done.
Thank you.
Mike, in space, instead of bread, the astronauts eat 1, crackers, 2, tortillas, 3, bagels.
Okay, I would guess it would have to be something soft and not crunchy so that the crumbs don't go everywhere. So crackers is out. I'm guessing tortillas because it has, again, the fewer particles, the better.
Tell me something. How much reading did you do before coming here?
I'm a nerd.
You're a nerd, okay. So we invited him about 4 weeks ago. I'm guessing you've been studying ever since, right?
No, that's just stuff I know. I read a lot about space, I'm sorry.
Okay, Clay?
The answer is tortillas. A, because
Bravo, Mike.
they don't make crumbs.
Yeah, what else?
But they also have a longer shelf life than any of the other items. So we want to take what we can take up there, and a tortilla makes no crumbs, and it lasts for a long time.
Yeah, and it's stretchable.
And it's flat, and so you can also put it in the food warmer, and so you can have warm tortillas, and you can put your food inside.
Nice.
Like a meatloaf sandwich. I put meatloaf inside my tortilla.
I'd have one right now.
Good. In space, after the toilet, urine is processed and 1, released to space, 2, become water for washing, 3, become drinking water.
Thanks to Chris Hadfield, I think we all know that answer. Become drinking water, right?
Correct.
Yes. See, I don't know the technical sides, you know, the distances and the time, but when it comes to urine, I'm your guy.
Would you like to comment on any of them?
Well, let's see. Urine is actually, when you take urine and break it down into brine and drinking water, process the water to drink, the brine still gets released to space because it goes in a spaceship into the atmosphere, it gets really hot, and it burns up and explodes. But drinking the water is a great way to recycle and means you don't have to bring so much with you.
An astronaut's uniform.
Yes.
How much does it weigh?
Oh, crap. We're back to the weight questions. Okay, are there choices? Can I guess?
You have to guess.
Oh, crap. How much does it weigh? Well, it looks cumbersome and huge and backpacks and all that. I'm going to go with 50 kilos. I don't know what that is in pounds. I'm sorry.
2.2 pounds per kilogram, so about 120. But
yeah.
In space, it weighs 0.
Oh, no. That was... Oh, come on. No.
How about
No, come on.
on Earth?
And then on the ground, you have to be more specific because we have a lot of spacesuits. So the suit that you launch into space and you return from space, it weighs about what you said, 100.
Oh,
Yeah,
I was
it's not
talking
very
about
heavy.
the EVA suit.
But the big spacesuit where you go outside and you carry your life support system with you and a helmet and gloves and boots and tethers and tools and all that sort of stuff, that's in the 500-pound range.
So, Mike, would you name 3 things that the uniform does?
Float. Well, it provides oxygen and pressure. It protects from heat, right? Overheating. And what's the third? Well, maybe pressure could be the third thing, but now I made them into 2 things. So crap. Yeah, sure, that counts. What
Okay.
else? What did I miss?
Right.
Oh, carbon dioxide. Yeah, sure.
So anytime you go outside, you obviously have to be able to live, so you need oxygen.
Life
you need
support.
to get rid of carbon dioxide, so we call that life support. You have to have the pressure inside the suit so your blood does what it's supposed to do. You have to have protection from micrometeoroids and the thermal communication, right? Because it gets almost to 250 degrees Fahrenheit in the sunlight and about 250 degrees below zero Fahrenheit when you're in the darkness. Then you have to carry your tools. You have to breathe the oxygen, and then you have to have a system like I have on my head. I feel really at home with all this stuff on my head because you have to be able to communicate with your fellow spacewalker and the folks on the ground.
I had a question.
Oh, and it has a diaper so you can poop and pee.
Yeah, of course. Well, that was the most asked question from my Instagram feed, unfortunately.
What is the lowest and the highest temperature at the space around the International Space Station?
Oh man, you just said it and I... Damn it. Do we have choices?
No, it's an open question, this one.
The lowest and the highest temperature at space around the ISS. I'm guessing on the sun side, it could get about 250 Celsius.
Fahrenheit.
And on the cold side, well, below 0. So I'm gonna go minus, not minus 250, no, minus 100.
100.
Yes.
Okay, what I have here is plus 100 Celsius and down minus 128 Celsius.
Okay.
Yeah,
What would you feel?
People, those numbers are a little bit flexible, but I usually, just because it's easier, I say 250 degrees Fahrenheit. So if you double centigrade, right, and add 30, that's 230, 250 degrees.
Yeah, okay.
And then minus 128, if you double it and add, you get about minus 250. So in the Fahrenheit scale, minus 250 to 250. And this one I'd use minus 100 to plus 100. I mean, it's government work, right?
Yeah. Okay. Now we're going to play a game which is known to all of us. It's called Taboo.
Are you going to do it in English?
Sorry?
You're going to do it in English?
Yeah,
or
in
Greek?
English,
I'm
yes.
okay, I'm good.
English is good because Greek would really suck for me.
Oh, yeah.
And so when you're ready, we can go.
Okay. It's the profession of one of the people on stage.
Astronaut?
Yes. A blank is born. Movie with Lady Gaga that came out this year. The Hollywood pavement has them.
A star.
Yes.
Yeah.
A star. Yeah. A star is
Right.
born.
Yes.
Crap. You use this vehicle to escape the Earth's gravity.
A rocket.
Yes. It lays eggs in your mouth and then its child bursts out of your stomach.
What?
It lays eggs in your mouth and then in movies. Sorry, I'm so sorry.
Oh, aliens.
Yes.
Yes. Time. Thank you. No, it's finished. 1 minute. We're done.
Yeah, we eventually NASA.
Mike, we're finished.
Oh.
Thank you.
Right.
That was great.
So, Clay, now is your turn. You should start from the one on top. Okay, when you're ready, Mike will be guessing, so go.
Outer
Space.
Earth satellite.
Moon. The moon.
Oh, there was
My bad.
It's okay.
A silly movie.
Space Cowboys.
With George Clooney.
Oh, Gravity. Thank you. Yes. Someone had to say it.
The Blue.
Lagoon. Expanse. No.
You dig with a shovel.
Oh, hole?
The blue sphere.
Oh, Earth.
Time. Thank you. Great. Let's give an applause for our guests. With this, I would like to thank our guests for tonight. Mikeius. Thank you. And astronaut Clay Anderson. And thank you for watching Celebrity Science. You can find more information about space and Clay's work at the bottom of this screen. And you can link to follow our YouTube channel here. Thank you very much for coming. Thank you.